All right, let's dive right into this word problem. Every time I have a word problem, I'm going to remind myself, I want to make sure I read, then draw, and finish up with some writing. So let's read this word problem together. You can follow along on your virtual engagement materials. In 1 year, a factory used 11,650 meters of cotton, 4,950 fewer meters of silk than cotton, and 3,500 fewer meters of wool than silk. How many meters were used in all three fabrics? So we've read the problem. Now let's pick out what we can draw from the problem. I know that the factory used cotton. Not only do I know they used cotton, they go ahead and tell me exactly how much. How much cotton did the factory use? 11,650 meters. I also know the factory used silk. I don't know how much silk the factory used, but they give me a great clue. What clue do they give me? Right, that there was 4,950 meters less of silk than cotton. I also know the factory used wool. Again, I don't know how much wool was used, but I was given a great clue. What clue was that? That there was 3,500 meters less of wool than silk. So I look at my drawing and I look at my word problem and I think, is there anything else I can draw? I look at the last part of the word problem that says, how many meters were used in all three fabrics? That's sending a signal to my mind. I could really use a tape diagram to show that portion. Why would I use a tape diagram? I'm looking to find in all. And this is a great representation for that. I know there was cotton. I actually even know how much. I know there was silk. That I don't know yet. I also know there was wool. Again, I don't know how much of that one either. So now it's going to be my job, after I have this great picture, to figure out how I can find the answer. The first thing I'm going to do is look at what I have. I know how much cotton I have. I know I have this much less of silk. So that's a signal to me. I want to do a subtraction problem to figure out how much silk I have. I'm going to pull out my handy dandy place value chart to do this first subtraction problem. I'm going to log on my place value chart 11,650 meters. Please know that I am always adding my units on. I see how many ones? 0. How many tens? 5. How many hundreds? 6. How many thousands? How many 10,000s? The next number I'm going to log on my place value chart is the difference, which is 4,950 meters. I'm going to log this on my place value chart. How many ones? How many tens? How many hundreds? And how many thousands? Please notice how I set up my number discs on the place value chart. I did them in the 10 frame way, helps keep everything organized. Now I'm going to go ahead and solve. Let's look at the ones. I have 0 ones I'm taking away from 0. 0, I'm going to log that on my place value chart. I have 5 tens that I'm going to take away from 5 tens, which leaves me 0. I'm going to log that on my standard algorithm. I get to the hundreds place and I notice I have 10 hundred, excuse me. I get to the hundreds place and I notice I have 9 hundreds. And I need to take that away from 6. I can't do that. Easy peasy. I'm going to come on over to the thousands place because I know if I decompose 1,000, that I can unbundle it to have how many 100s? 10, correct. So how many hundreds do I now have? 16. Let's go over to our standard algorithm and show that. We have 16 100s. So we can take away 9. Let's go ahead and do that. Which leaves me with how many hundreds? 7. Let's log that on our standard algorithm. When I get to the thousands place, I realize I decomposed the thousands I had. I don't have any more. I have to log that on my standard algorithm. I also notice I need to take 4 away. I don't have them. So again, I'm going to decompose. I'm going to go to the 10,000s place. I'm going to take that 10,000, decompose it, and how many thousands will be available? You are right, 10. Let's go ahead and log that on our standard algorithm over here. Now I'm going to take away 4, and I see I have 6 left. I see that my answer is now 6,700 meters. Let's take this information and log it into our picture that we drew. We now know that we have 6,700 meters of silk. We can also put that in our tape diagram. The next thing we need to figure out is what? Well, how much wool we have. So let's look what we know. We now know how much silk we have, and we know that is how much less wool we have. So we can do another subtraction problem. This time when I do the subtraction problem, I'm not going to draw a place value chart. I'm going to use the standard algorithm. I do have that place value chart in eyesight. It's a great visual to remind me of what I am doing. I'm going to solve 0 from 0, 0 from 0 in the tens. I'm going to take 500s away from 700s, which is going to leave me 200. And I'm going to take 3,000 away from 6,000, leaving me 3,000. I now know that we have 3,200 meters of wool. I'm going to put that back into my drawing. As I look at my drawing, I say, am I done? Have I finished? Well, let's look back at that word problem. It says, how many meters were used in all 3 fabrics? Although I know how much of each fabric, I don't know in all yet. So to do that, what do I need to do? I need to add all the pieces of the tape diagram together. To accomplish that, again, I'm going to go back to a place value chart, and I'm going to place them on the place value chart. First, I'm going to place the cotton. I see 0 1s, 5 10s. How many hundreds? How many thousands? How many 10,000s? The next I'm going to log is the silk, and we determined there was 6,700 meters of silk. I noticed 0 1s, 0 10s. There are 7 hundreds and 6 thousands. I also need to add into this that last piece of the tape diagram, which was the wool. 3,200 meters of wool. I see 0 1s, 0 tens, 2 hundreds, and 3 thousands. I've logged all my numbers onto my place value chart, so I'm going to go ahead and solve now. I look in the ones place. I have 0 ones. I look in the tens place. I have a total of 5 tens. I'll go log both of those on my standard algorithm. 0 ones, 5 tens. Then I'm going to go to my hundreds place, and I notice right away, let's see, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And a little alarm bell goes off in my head because I know if I put 10 100s together, I can bundle them and make 1,000. So I'm going to go ahead and do that. I'm going to take 10 100s. I'm going to bundle them together and turn that into a bundle of 1,000. I now see that I have 500s left over. I log that on my standard algorithm. There's my 500s. And then I'm also going to show the 1,000. Now I'm going to come to the thousands and count that up. I see that I have 6, 7, 8, 9, 10, 11. Again, there goes a little alarm in my head. I know I can bundle 10 1,000s together. And when I do that, it becomes 1 10,000. I now see I have 1 left over. Log this on my standard algorithm. There is my 1,000. And then here is that new bundle I created of 10,000. I look in my 10,000 place and I see that I have 2. So I'm going to log that onto my standard algorithm. And I am never going to forget to make sure I add my units. So now I see that I have 21,550 meters. Well, of what? Let's go back to our picture of fabric. In all, I have 21,550 meters of fabric. Am I done? Not quite. We're really close. Now we need to write what this is showing us, what the answer is. They are asking us in 1 year. So let's write that in 1 year. The factory used 21,550 meters of fabric. So I read the problem. I drew a picture to represent the problem. We solved using subtraction, addition. We used the place value chart. And then once we came to our conclusion of our answer, we wrote it out. Nice job. Thank you all for doing that problem with me.